Hi everybody, I have something I want to show you, and save this if you need it, but this is going to be a strategy for people that struggle with math, or have dyscalculia, or as it's also pronounced dyscalculia. But what it will do is going to help you better see the math problem. And what I mean by that is it's going to pretty much block out everything else but what you need to look at. So, I'm going to model this, but first, I'm going to get into a little bit of background knowledge about dyscalculia. Dyscalculia is a math disorder. It's a learning disability where a student struggles to understand math concepts. They have a hard time telling left from right. They perform extremely well in every other subject, but for some reason their math grade is always really, really low, and they're always somehow behind their classmates, and there's nothing wrong with it. I struggle with the same problem, and that's how I came about finding out I have dyscalculia. My dad has it as well, and he taught me this to help my students in the future, and so I thought, okay, cool, I might just, teach this and help everybody else too that may not know this method. And I call it the paper method. So you take a piece of paper. It doesn't have to be construction paper. It can be notebook paper. It can be lined paper. It can be composition notebook paper. It can be printer paper. I just chose this because it's bright and it's easy to see. Now, I'm going to model on the board first, then I'm going to show you how to do it on paper. So, we're going to use this problem. It'll make more sense if I actually use the paper for this, but let me grab a magnet here. Alright. So I put our paper on here. Now see how there's all these problems? People like me are going to sit here and go, oh my god, I have no idea where to start. Well, with this, I'm going to put the line work exactly where I want it. Now I made this a little too small, and you can make it bigger. It's needed. Now all I can see is the problem I need to work on. So now that I know what I need to work on, I can come over here on my board, and I can come over here and I can write what I need to. See? So it blocks out all the other problems so that all you see is the one you need to work on. And you can move it down line by line. But let's do this. So we know that 8 and 8 is 16. 16 minus 2, that's 14. That's another way I do math. Alright, and then 7 and 4, 11, 12. And that's how you can solve math problems using the paper method. Now, not only does it work for simple problems like that, so let me go ahead and write our answer on the paper. It also works on word problems. So, what you'll need is a bigger section. So, I'm going to go grab another piece of paper, and I'll show you how to model it for word problems. So, I have our piece of construction paper here. You just take it, and since we're doing word problems, we're going to need a bigger box than what we had last time. And I've probably already messed this up, and that's okay. Okay, yeah, I did mess that up. Alright, so, that happened. Alright, so we'll just go back to our orange, since I cut it the wrong way. But, if you're trying to make a box for word problems, cut this out. Let's grab our word problems here. you're going to need probably a bigger box. So, give me 1 second. And it's okay, you can, you may have to cut the paper 5-6 times. But you know what? That's alright. Cool. Alright, this is a bit better. So, actually, we'll set it like this. But, you get the gist. You'll need to make it bigger, like I did. But that's kind of what it'll look like for word problems. So, not only does it work for that, another method I use, and this is personally how I solve math problems, because once again, like I said, I struggle. And so, not a lot of people do this, and some people get confused when I explain how I do it. So, we'll do 73 plus 93. So, for example, we know that 3 and 3 is 6. So, we're going to put that down. Now, 7 and 9. Okay, well, I know that 7 and 7 is 14. Okay. But our number is 9. So, we need to add 2 to that. And that's kind of how I do it. So, I take what I already know, and then I subtract from what I know. So, I know that 7 is 14. I know that 7 and 8 is 15. And now I know that 7 and 9 is 16. But if you don't know that, but you do know 7 and 7, well, that's 14. Now you know you have a 9. So, you're just going to add the 2 to the 14 to get 16. And so you put your answer down. And our answer is 166. Now this also works for subtraction. Not as well, but it does work. And so I'll show you another one. And this time with subtraction. And like I said, this method may help students with dyscalculia. And my dad, he of course taught me that method, but then the other one I have been doing my entire life, the whole take what I know, subtract, and then add again. Been doing that one my whole life. Alright, we're going to do 63 minus 34. Well, here's our first problem. We got to borrow. Our 6 becomes a 5. Our 3 is now 13. Now we have to figure out what 13 minus 4 is. Well, we can count on our fingers. So, 12, 11, 10, 9. Or, we could do 4 plus blank equals 13. Well, we know that 4 and 6 is 10. We know that 4 and 7 is 11. 4 and 8 is 12. Well, I guess that means 4 plus 9 is going to equal 13. So, you can do it that way too. Go off what you know. And that's kind of what I do. So now that we got that, and now that we borrowed, now we're going to do 5 minus 3, which we know is 2. Which gives us our answer of 29. Which means 34 plus 29 will equal 63. And so vice versa, like we just did with the subtraction. Now, let's do another one. Let's do an easier one. Actually, we're going to do multiplication, because I know a lot of people struggle with the multiplication one. Now, I don't have a multiplication sheet printed out right now, but we're going to do 2-digit. We're going to make it work. Alright. So, 12 times 11. Okay, well, we know that 2 times 1 is 2. It's itself. We know that 1 times 1 is 1. Okay, and now our x is dead, so we cross it out. We bring down a 0. 1 times 2 is 2. 1 times 1 is 1. Well, now we do 2 plus 0 is 2. 1 plus 2 is 3. We bring down our 1, which gives us an answer of 132. So I call it kill it, bury it, bring it down method. Or if you're looking for a more appropriate name, the get rid of it, drop it, bring it down. Let's do another one. Let's do... I'm going to do a harder one. 16 times 13. Well, we know that 6 and 3 is 18. 8. I bring the 1. 3 times 1 is 3, plus 1 is 4. Oh no! 3 has fallen off. 3 is done. He went home. Okay, so now that 3 has went home for the night, and he's no longer there, well, we're going to have to use his buddy. So his buddy is going to tell us that 1 times 6 is 6. Now, I cannot obviously line up my numbers. I suck at place value. I had to teach myself that. Okay, now that we know that 1 times 1 is 1, let's get rid of our arrow. 0. Oh, we came across 8 and 6. Well, know that 8 and 8 is 16. So we're going to minus 2. And that gives us 14. So we put down our 1. Bring over our other one. Put down our 4, bring down our other one. Well, we know that 4 plus 1 is 5, plus 1 is 6. Our answer is 640. Now, I call this method, if you want a more appropriate name for school, get rid of, go to bed, bring down. So, we got rid of 3. He went to bed. Then we brought down what was left, which means we put a 0 as a placeholder. So that's all that is. Get rid of, go to bed, and bring down. And do the same thing with division. But I will do another one using our little method here. Little paper method. So, let's see. And I know that I messed it up, so... There we go, there's our little paper box. 17 and 50. Well, that's the wrong orientation. That's if you want to do it that way, if you want to add it over top. Well, okay, 7 comes down, that's 7, and 17 and 50 is, yes, I'm going to say it's 67. But I thought that paper method might be useful. It's helped me, so I figured it's a cool method my dad showed me to help students with dyscalculia. So I figured it might be useful for other people. But that's it. Thank you for tuning in.